Welcome students, I am Vibhuti CP. I am going to teach you the one more course of the MSc first year, that is CHI 130 main group elements. So uh, we already discussed the syllabus included in your first year. Okay, from that the course 150 CHO 150, the second part will taught by me, and also I'm going to teach you the another course of MSc first year, that is CHI 130. This course is the course of inorganic chemistry, semester first. It includes the two section. The first section is molecular symmetry and the second section is chemistry of main group elements. This is also the 4 credit course. In the first section, this is 2 credit course, that is the molecular symmetry and its application. This course will taught by the Professor Sane BV, and here I am just explaining you the topic included in this section. First, you have to learn, that is molecular symmetry and symmetry group. It includes the number of symmetry operations, plane, reflection, inversion, proper axis, proper rotation, etc. The second is representation of a group. It includes the matrix representation, matrix notation for geometric transformation, great orthogonality theorem, etc. Also, it includes some symmetry adapted linear combination. It includes the SALC for sigma bonding of D2H, D3H, D4H, C4V, tetrahedral, octahedral, and also the transformation properties of atomic orbital MOs for sigma bonding. And the last section is the application of the group theory to IR spectrometry. In that topic, you have to learn the introduction, selection rule, polyatomic molecules, and the symmetry of vibration and their IR activity. All these topic will taught by Sane madam. Okay, I am going to teach you the second section of this course, CHI 130. This is also the 2 credit course. The name of that course is chemistry of main group elements. Okay, the first topic we are going to learn, that is hydrogen and its compound. Here we are going to learn the classification of hydrides, electron deficient, electron precise, and electron rich hydrides. Second topic is alkali and alkaline earth metal. It includes the solution of in non-aqueous media and application of crown ether in extraction of alkali and alkaline earth metals. And third topic is boron group or the boron family. Here we are going to learn the boron hydrides, their preparation, structure, bonding with reference to LUMO and HOMO. Also, we learn some higher borane, metalloborane, carborane, and the reaction of organoboranes, and the Sticks rule and the structure of the higher borane. Next topic is carbon group. It includes allotropes of carbon, graphite, graphene, fullerene, nanotube, synthesis properties, single structure walled and the multi-walled and its application, intercalation compound, etc. Next topic is nitrogen family or nitrogen group. It includes nitrogen activation, boron nitride compounds, Pn and Sn compounds and their applications. Next topic is oxygen group. Here we are going to learn the metal selenide, telluride, oxyacids and oxyanion of sulfur and nitrogen, ring, sketch and cluster compound of the p block elements. Next topic is halogen group. Here we are going to learn the interhalogens, pseudohalogens, synthesis, property and applications, and the structure of oxyacid and oxyanion. The next topic is noble gases. It includes the occurrence compounds of xenon with the fluorine and oxygen and its uses. Okay. Next topic is the organometallic compounds. It includes the organometallic compounds of lithium, magnesium, silicon, lead, arsenic with the classification and also their structure, synthesis and properties. Here some references you can refer, that is Inorganic Chemistry by Atkin and Shiver, Concept Inorganic Chemistry by the J.D. Lee. Both of these books are also very good book for the referencing. All the topic are included in that books. Next book is Inorganic Chemistry by Principle of Structure and Reactivity by the Mehdi. Here you can for the organometallic you can refer this book by the Christoph, and the organometallic by Concise Introduction by Christoph. Okay. Basic organometallic chemistry by B.D. Gupta. You can refer all these. Some of these books you can buy or you can take from our library. Okay. Here, so this is about the syllabus. So let's start our topic, that is main group element, that is called as a p block elements. Okay. Here let's see the position of the p block elements. You already studied in your from 11th class up to the TYBSc the position of p block in a periodic table. Okay. At the left side, this is the S block element. This includes alkali and alkaline earth metal. At the center there are the transition elements. This is also called as a D block elements, and to the right there are the P block elements. Okay, these are the combination of metals, non-metals, metalloids, okay, and the inert elements. And the bottom of that, here these are the F block elements. Okay, here we are in this section we are going to learn the p block elements. It includes the boron family, carbon family, nitrogen family, oxygen family, fluorine family, and some noble gases. Okay, some important topic from that all these families we are going to study. Okay, before to start the p block element, here we learn the hydrogen and their hydrides connected, or hydrides made with the element from the p blocks. Okay, so start our first topic, that is hydrogen. Hydrogen is a simplest known elements, exists as a diatomic molecule. Hydrogen molecule is a colorless, odorless and non-poisonous gas. At 1 atmosphere, the boiling point is minus 252.9 degree Celsius, the most abundant element in the universe. Here, the ground state electronic configuration of hydrogen is 1s1, and this is the hydrogen having negative charge, that is called as a hydride ion. This is isoelectronic with the helium. This is found in a large number of covalent compounds. Here, how to prepare the hydrogen gas? There are some reaction for the reference. Here, this propane, which is on hydrolysis or reaction with the water, there is a formation of the hydrogen gas. Also, the carbon which on hydrolysis, there is a formation of carbon monoxide and releasing the hydrogen gas. Also, this metal, zinc metal, is reacted with the acid, that is HCl. There is a formation of the hydrogen gas. Okay. Next, here we are going to learn the hydrides. What is the hydrides? Hydrides are or is an class of chemical compound in which hydrogen is combined with the another element, that is called as the hydrides. There are three basic types of the hydrides are there. Here these are how the hydride is formed. Here the first of all, the hydrogen atom which leaves the electron, there is a formation of the H plus ion, that is called as a proton. And whenever this hydrogen atom which accept the electron, that time there is a formation of H minus, that is called as a hydride ion. Okay, these are the hydride ion. These hydrides are divided into the three types. First, that is a saline or ionic hydride. Second is metallic or interstitial hydride, and third type is molecular or covalent hydride. Here the saline hydride, that means what? The hydrogen is combined with, here the hydrogen is combined with the metal and non-metal, that is called as a saline hydride. Whenever the hydrogen is combined with the p block elements, that time it is called as the hydride which is formed is called as a covalent hydride. And whenever the hydride which is combined with the d block element or the transition metals, that time it is called as a metallic hydrides. The hydrides are divided into the three types. Saline, that is ionic hydride, whenever this hydrogen is combined with the alkali and alkaline metal, that is a s block elements, that is called as a saline hydride. Whenever this hydrogen is combined with the element from the p block, that time it is called as a covalent hydride. And whenever this hydrogen is combined with the d block element or the transition metals, that time the hydride which is formed is called as a metallic hydride. Okay, next here we learn first, that is a saline hydride. What is a saline hydride? Here the saline, it is also called as what? The ionic hydride, are defined as the presence of hydrogen as a negative charge ion. The saline hydride are generally considered those of the alkali metal and the alkaline earth metal. Hydrogen is combined with or make a bond with the alkali metal and the alkaline earth metal. Okay, that is called as a saline hydride. This metal entered into a direct reaction with the hydrogen at the temperature 300 to 700 degrees Celsius to produce a hydride of a general formula MH or MH2. Okay, they having a formula MH and MH2. Okay, here you can see the reactions of some saline hydride. Whenever two metals which is reacted with the two hydrogen, there is a formation of a 2MH. This is the exothermic reaction. For examples, lithium, two lithium reacted with the hydrogen, there is a formation of 2LiH. Okay, this is the lithium hydride. Also here the calcium which is treated with the hydrogen, that time there is a formation of the calcium hydride. Calcium reacted with the hydrogen, there is a formation of CaH2, calcium hydride. Okay, these are some examples of or preparation method of the hydrides. Here there are some reactions of the hydrides or ionic hydrides. First, that is calcium hydride which is treated with the calcium chloride, there is a formation of what? CaHCl. The color depends as polarizability of the anion and cation increases. Okay, the saline hydrides also react violently with the water producing a dihydrogen gas. That is the sodium hydrides, which is reaction react with the water. There is a formation of the sodium hydroxide and there is a formation of the hydrogen gas. Okay, this is about the saline hydrides. Next is the covalent hydrides. Covalent hydride means these are primarily compounds of the hydrogen and non-metals. This is a compound of what? Hydrogen and the non-metal, in which the bond are what? Evidently electron pair shared by atom of comparable electronegativity. That means what? Here the hydrogen is combined with the non-metals. There is a formation of covalent bond between the hydrogen and the non-metals. Okay, that's why it is called as a covalent hydrides. For example, most non-metal hydride are volatile compounds held together in a condensed state by relatively weak van der Waals intermolecular interaction. Okay, here this covalent, or it is also called as a molecular hydride, are divided into three types. First, that is electron deficient hydrides. Second is electron precise, and third is the electron rich hydride. In electron deficient, it is formed by a hydrogen is combined with or bond with a group 13 elements. For example, B2H6. They act as Lewis acids. Here they are electron acceptor. In a group 13, they are electron deficient group, and that's why they are the group acceptor. That's why they act as Lewis acids. Second type, here the electron precise. This is formed by the combination of the hydrogen and the group 14 elements. That is, example is the CH4. They have a tetrahedral geometry. And the third type, that is electron rich, which is formed by the combination of hydrogen and the group 15 to 17 elements. Examples are ammonia and the water molecule. They acts as a Lewis basis. That is, they are electron donor. Let me learn one by one. First, that is electron deficient covalent hydride. Here all the element of the group 13 will form electron deficient compounds. That means what happened here? This boron, which is form a bond with what? The hydrogen. This boron, which having a less number of electron, and that's why this is acts as a Lewis acid. They acts as a Lewis acids. Okay, this is the structure of diboron, B2H6. Okay, next is what? The electron precise covalent hydride. That means electron precise compound have the required number of electron to write their conventional Lewis structure. All the element of group 14 form such a compound. That means what? Here for completing the valency of carbon it required what? 4 hydrogen or the CH4. Okay, this whenever this 4 hydrogen is combined with the carbon, they completed their valency, and that's why there is no need of any acceptance of the electron and the donation of the electron. That's why it is called as electron precise covalent hydride. Okay, the next one is electron rich hydrides. That means what? The electron rich hydrides have the excess electron which are present as a lone pair. Okay, element of group 15 to 17 form such a compounds. Here in case of ammonia, here this ammonia, the nitrogen is combined with the 3 hydrogen, and nitrogen contains one lone pair of electron extra. One lone pair of electron. This is extra. Okay, that's why it is called as electron rich hydrides. Okay, for example, water also contain 2 lone pair on the oxygen. That is, extra lone pair are present whenever the molecule is formed, that is called as a electron rich hydrides. Okay, the third type, that is what, the metallic hydride. Metallic hydride, that means these are the transition metal and the inner transition metal form a large variety of a compound with the hydrogen, that is called as a transition metal or the metallic hydrides. The metallic hydrides are formed by heating hydrogen gas with a metal or their alloy. Here, the metallic alloy like hydride possess some of the characteristics of the metal, such as luster and strong electrical conductivity. They tend to have a variable physical property, and some being more brittle and other being harder than the metal from which they are made. The metallic hydride essentially consists of a proton, that is a positive hydrogen ion, and the metal atom is in a electron C. Okay, here the metallic hydride, which is mostly combined with what, the transition metals. These metals, the how it is formed, it formed like this manner: M plus X by 2 H2, there is a formation of what, M HX. M may be what, the transition metal, like, or the inner transition metals like titanium, uranium, praseodymium, palladium, etc. Also, some these are some non-stoichiometric metallic hydride, and some stoichiometric metallic hydride also possible, like TiH2, UH3, PrH2, etc. Okay, this is about what, the metallic hydride. Here there are some applications of metallic hydrides. First is the hydrides such as sodium borohydride, lithium aluminum hydride are commonly used as a reducing agent and in a chemical synthesis. Second is the hydrides such as sodium hydride, potassium hydride used as a strong basis in organic synthesis. These hydrides react with the weak acid releasing hydrogen. Next application is the hydrides such as calcium hydride are used as a drying agent to remove a trace water from organic solvent. The hydride react with the water forming hydrogen and hydroxide salt. This is about the applications of the hydrides. In this lecture, we learn the syllabus, and also we start our topic from the hydrogen, the preparation, and hydrides. Here we learn hydrides. There are the three types of hydrides: saline hydride, covalent hydride, and metallic hydride. We also learn the types of covalent hydrides, that is the electron rich hydride, electron precise hydrides, and electron rich hydrides, electron deficient hydrides, and also we learn their applications. Thank you very much for watching this lecture. Also, you has to comment on this lecture as writing your name and also your roll number. Thank you.